Hello, everyone. As Josef already introduced me, my name is Janis, and I represent a company that comes from Riga, Latvia. It's called Baltic 3D. We've been in the 3D printing business for the last 3 years, and as you saw from Andreas' presentation, that 3D printing has been around for quite a long time already. No earlier than the early 80s already, right? How we started to get into the 3D printing was that we saw it as a really emerging market in the world, and we wanted to have part of it. So we started researching and investing in the field, and right now we are the largest 3D printing service provider in the Baltic states. Baltic 3D has more than 13 different industrial printers available for 3D printing service provision, and we started with the bare fact that we knew that we cannot buy a single multifunctional printer, and how we wanted to solve the problems of our clients was that we wanted to provide them anything that they would need in terms of applications. In the previous presentations, you saw a lot of examples on how many materials, how many printers you have out there. Basically, there's, as I already told you, there's no one printer that can do all the tasks that you might need of a 3D printer. There's also no one printer that can print in all the materials. And therefore, we started growing our partnership network, and we managed to secure agreements not only with Stratasys 3D systems and EOS printers, but we have a lot of different sort of machines that we can actually use. With this logic, I also want to say thanks to the organizers, because this is the first time when we actually get to meet one of the biggest competitors for the company that we represent. We're the official resellers of one of the largest 3D printing 3D printer producers in the world, which is Stratasys. The other bigger company in the world is 3D Systems, and we're really happy to see here in these two global companies represented here in Estonia. So I will give you a bit more feedback on where we're coming from, and then why my next presentation is going to be so specific, especially about one application. So through the years, we've been working with different clients, and most of our clients come from industries that are local to the Baltic region. Those are electronics manufacturers, those are injection molding companies, and those are quite many companies that produce products that I would say do not have a lot of R&D involved in the process of product making. What I mean with that is that in the Baltic states, maybe not as much in Estonia, but especially in Latvia and Lithuania, we have many companies that produce products that are designed and researched outside of Baltic states. Because of the cheaper labor here, we have a lot of R&D sitting outside the country, which means that there's way less need for 3D printing, which concerns functional prototyping. And there's only maybe a handful of industrial 3D printers throughout Baltic states that can actually be used for other serious purposes rather than only functional prototyping. Therefore, I want to touch upon a more local application. I want to touch upon an application that's called jigs and fixtures, and I want to touch up on an application that's called injection molding on 3D printed molds. So I will start off with showing you. Oops. Yep, I got it. The red dots. Yes. I'll start off by showing you a small video of what jigs and fixtures are and what they're used for. But bear in mind that this is deeply industrial application. It uses industrial materials for this application, and it uses it can be applied mostly to actual production lines. So it's an application that can optimize and help to an existing production rather than replace a production. So we're not talking here about production replacements. This is also an application where you can quite easily prove from the economic standpoint how does this justify to buy or to use a 3D printing and printer in the production process. This application, if we pick any production, there's probably something that you can print that either is a fixture or a jig or a tool or both of them in a production line. And I'll show you the video first so that you have the understanding of what I'm talking about.
Manufacturing relies on jigs and fixtures to maintain high levels of quality and production efficiency. Time is money, and money is money too. With FDM jigs and fixtures, you can save both. FDM works great for complex and organic designs, and it can perform as well or better than your traditional jigs and fixtures. Here's where manufacturers do.
That was not supposed to happen. Okay, maybe you can play back error. Okay, let's just go ahead. So first of all, what is a jig? It's basically it's a tool that is used to fixate an object on a production line or on a workbench, where you can where a worker or a machine can work on this particular item. It can be also a fixture that holds a product while it's traveling along the production line or while it's being transported from one workshop to another one or from one workstation to another one. Basically, all manufacturing industry relies on some sort of jig and fixture. A pallet, a wooden pallet, is also a fixture of sorts that helps you to transport tools from one place in the production to another one. As it says here in the bottom, these tools are particularly basically invisible in the production line because those are complementary tools. And rather than being manufactured, they're oftentimes made by hand, and they're oftentimes heavy machinery or outsourced of the company. You buy ready-made tools, which often limits you to a certain, application of this exact jig or fixture. And I'll give you a couple of examples later. But basically, you can see all the departments that would be in a normal production company are mentioned there, and you can use all of them in there. These kind of fixtures include assembly aids, alignment fixtures, holding and nesting fixtures. A lot of these kind of printed fixtures are used for inspection, and not only for measuring inspection, but also for environmental testing. You have, as I told you already, transportation jigs and fixtures, which are part holders, end of arm tools, assembly line, pallets, tool holders, and other. On the right side of in the pictures, you can see that it's either on the production line or below the white part. It's an actual tool holder there. What we see, for example, in a couple of our clients, and these are some truly global companies that use these kind of applications, is that, for example, there's an electronics producer that produces LED lights. They need a specific type of material, which is called ESD, which doesn't allow static electricity to run through any parts while in the production. So in a sense, they are able right now, instead of making those fixtures out of wood or buying off-the-shelf products, they're able to adjust the fixture with using 3D printing to every new product that they launch on the production line. It's not only about when we produce product A or product B or product C, it's also when we start producing new product like product D. And one of the best reasons to use this is that you can make a digital digital database of different fixtures that you would be using for different type of products. So you're not actually having, you don't actually have to store them in anywhere in the company. You can, whenever you start producing this older product or a new product, you just print the new fixtures, new tool alignment jigs, and you are ready and set to print. Conventionally, they are produced, as I already told you, from wood. That would be mostly by simple tooling or by hand. You can CNC them out of plastic or metal. Outsourcing of these kind of jigs or buying off-shelf products is oftentimes expensive. And in-house, depending on what kind of industry you're operating in, it can be a big expense on the production line. For example, for a client that I mentioned, they're spending a lot of time, they're actually doing a lot of idle time on the production line just because they cannot produce the jigs fast enough, and 3D printing solves their problem. So instead of waiting for 3 days to this outsourced company to provide them a CNC machine jig, just push the print button and a new jig is there the next morning and they can launch the production with a new product. Jigs and fixtures are mostly, on our client side, are mostly printed by FDM systems. FDM systems use thermoplastics or strings of thermoplastic which they melt and build up the product. And we have a lot of different material applications that you can use there. We can start with the simplest ABS plastic that would also be the cheapest for any this sort of application. So, but in the meantime, we can also go for very specific materials. As I mentioned already, there's material called ESD that doesn't allow static electricity run through the jig, which is really helpful for most electronics producers. So while you're running that hard drive down the production line or that LED rig, you're actually not getting any static electricity. Additionally, there are jigs and tools and fixtures that can be printed from materials like Ultem or polycarbonate that are really stiff, and that can actually be stiffer and more resistant to wear than aluminium, for example. And many times these jigs are actually CNC'd out of aluminium just to save on the money side instead of CNCing them out of stainless steel, for example. And the good part about 3D printed jigs is that you can re-engineer those kind of tools out of the actual designs that you already have in-house. So when you're doing a new product, you most probably have made a 3D design, either to do a functional prototype or either to do some pre-manufacturing testing. And if you have this 3D model, you can re-engineer the jig and the fixture around this particular object or this particular product, which means the overall time from an idea to start the production until you actually have calibrated the production line and start producing the product takes much less time. There are also some stats on how long it usually takes to implement these kind of tools. So on the right side up there, you can see a fixture that is used to glue the BMW sign on the back of the car. And I'll try to show you the old version. I really have it somewhere on the pictures here. Okay. Not there. Obviously, we kind of talk about big car manufacturing here in Baltics, but just to make a good example, there are probably 50 to 100 workers that work with these kind of gluing tasks every day. So one thing is that you can make this, you can actually 3D print that much of these fixtures for every one of your workers. We can go even to extremes. If you have different hand sizes for each worker. You can actually print, customize tool for every worker that works in the production line. The size can vary, obviously, but it's largely dependent on the 3D printing system that you have in-house or that you're outsourcing. But it can be up to 30, even 50 centimeters in size. And the thermoplastic strength is most of the times completely acceptable compared to metallic and then wooden rigs or jigs that you would be using traditionally. The general time and cost savings, and I'll show you. I have this actual fixture there in the room next to us. If you, after the presentation, you're more than welcome to step up and I can tell you and show you exactly how it looks like. We have a CNC jig and we have a 3D printed jig, and the average cost saving and time saving is up to 90%. And we have also a huge cost reduction there. And obviously, these kind of processes can be very easily streamlined and made more efficient. If you needed a specific person to calibrate the CNC machine and actually to make sure that the final jig is assembled and on the production line and accessible to everyone, then when you're using 3D printers, for most 3D printers, and I'm talking about industrial machines, it's as easy as pushing that print button in your Word document when you want to print it. So it doesn't require a lot of training to allow your factory workers to have a system sitting next to the production line. And whenever you have a need for a broken fixture or a tool, you can just push the print button, and within 5 or maybe more hours, or maybe for the next morning, you already have the new tooling ready. And as mentioned before, the digital inventory. So you can optimize your location, your premise space. Just dancing around. And yes, on the picture at the top, you can actually see the old jig that was used to do this. You can try and count how many parts are there, but there are quite many parts. So one of the first things that you can do with 3D printing, which is limitless in most cases, is you can consolidate a lot of those small parts. You can integrate features. So for example, on the bottom part, you can see a hard disk drive rig that not only allows you to place 2 different parts on each side, but it also has a small hole where to put the screws in. And this can actually drive down the production line to the next workstation if needed. You can very easily introduce text and labels and signs into these kind of jigs, which then allows you to very quickly convey information, especially if it is used for training new employees. You don't have to have anything else but a printed part on the table. And obviously ergonomics. As I told you, if you can go as far as customizing the tool for every worker you have, or if the worker wants, he maybe can customize his workbench by printing out a different fixture for his new tool set. I hope this video will run, and then we can actually show you one example of a company called Orec, which is a company out of United States that is using 3D printing machines to optimize their production. But not only production, also testing and also logistics. They have previously used up to 20, 30 injection molded parts, which means that they have the injection mold sitting somewhere in an outsourced company, or they have the injection molded part, injection mold sitting somewhere in their storage room, and whenever they would need it, they would actually bring it out and then use it, and it takes time. What is more, in case they maybe change some of their products, if they come up with a new vacuum cleaner, they would probably need to make a new injection mold. Instead, when having a 3D printer in-house, they can just do this specific print that they need, and they can quickly make new tooling. Meanwhile, if you have the 3D machine on hand while it's sitting and not printing tooling for you, you can use it to prototype. Because if every 3D printer can be used in one or other sense for prototyping, more or less functional, then not every 3D printer can be used for industrial applications. And it's largely connected with the materials that you can use in a particular printer. But if we go back, then you can see here. But you can see the product quality management is also a big part of their business for this client. So they were able to print all the fixtures, and even the tooling that holds the measurement heads for the robotic arm. They were able to print those parts in order to save money and time. So in comparison to aluminum CNC machine tooling, they are actually gaining almost half the time that they would be spending on CNCing it. They're gaining more than 70% in cost savings, and the inspection times that they're getting out of the new tool are incredibly shorter. So this is 32 days to 1 day. I'll try and show you how they achieve this, if the video works.
Oregon manufactures the best vacuum cleaners in the world. We're the only manufacturer of vacuum cleaners in the United States, and we make the lightest weight, most powerful, simplest vacuum cleaners available. Stratus systems here at Oregon helped improve our new product development and even some of our sustaining product capabilities. One of the things we can do here is we do not have to do drafting, some of the radiuses and things and sharp corners that we might do in a new design. So we're able to create new parts very quickly and can test those parts from the design side. I use FDM here to build fixtures to measure our parts for our uprights and for our products on the coordinate measuring machine. With traditional measuring methods, a lot of times we couldn't do any programming with the CMM to do first article inspection until the parts were actually made in the new mold. That could lead up to well over a month of bottleneck. Everybody's waiting on first article inspections. FDM, we can make the fixtures, we can make prototypes of the actual parts before the molds are even made. And then when the parts come in the door from the actual mold, I'm ready to go. I can just bolt the fixture on, put the part on, press the go button on the CMM, and then I can knock all the parts down to maybe 2 days. Beyond new product development, we also use rapid prototyping to be able to help place our products for assembly on parts, things like that. It provides the capability for our assemblers not to have 5 hands to be able to put parts together. Using the Stratus system helps us in a lot of ways. A lot of these nets have some complex shapes to them, and typically if you were to ask a machinist to machine one of these out, you could easily spend a day on each one of these nets. Where with the Stratus system, we can turn out multiple of these, of course, per day. If you're considering using the force for manufacturing, I would highly recommend it because it's beneficial in a high-paced, fast-moving environment. FDM uses go well beyond the new product development stage. Assembly, manufacturing, quality control, that type of stuff is better, cheaper, and easier to manufacture, quicker than any other process that we've used.
A quick summary of the video. As you saw, one of the points maybe I didn't make as clear was that not only they produced the tooling, so why was the long waits in 1 to 30 days? It's because they were able to print out not only the jig, but they were also able to print out the prototype and start calibrating the quality control systems for them to be ready when the actual manufacturing starts. So as soon as the parts arrive at the quality control, the calibration machinery is set to go, and they're ready to roll out their product. I have another video, but it's okay? Okay, I'll show you another one. This has a bit wider examples of how to use it, not only from one company. What you can see there is how a printed fixture is being used in the production process of 3D printers. So these are actually 3D printing heads being placed in a fixture that are going to travel through the production plant to the workstation where they're going to be installed or packed for sales later. Okay, we'll try this.
Wherever there is a need to hold, position, place, or organize, you will find jigs and fixtures. They are used by nearly all industries: aerospace, automotive, consumer products, medical devices, and healthcare, just to name a few. Within a company, you will find them in research and development, manufacturing and assembly, inventory control, quality control, and transportation. We'll walk you through a few of those departments. Tools that once were traditionally fabricated out of wood, plastic, and metal, either with hand tools or machine tools, are being made with FDM. By simply substituting FDM for traditional processes, companies are producing jigs and fixtures faster and at a lower cost. And they're making far more of them because of the ease and efficiency. Before launching a new product, extensive research, development, and testing are performed, and FDM jigs and fixtures are there to help. From fluid line mounting fixtures to gauge mounting fixtures, check gauges, and fan testing rigs. Need to test a light bulb or specialized hardware? FDM can make a fixture for that too. The durable FDM plastics are perfect for your life cycle testing. Fans, keypads, vacuum cleaners, and many other products. When testing reveals a need for a change, simply 3D print another FDM jig or fixture for the next go-around. On the production floor, FDM jigs and fixtures make work easier and safer. And companies that use FDM find that they have more of them than ever, since they're so easy and inexpensive to make. Make a masking tool for conformal coating electronics and cut out manually taping each printed circuit board. Or build a dispenser for factory floor labels. For assembly operations, use FDM for nesting assembly fixtures, rivet guides, or assembly guides. Need a one-of-a-kind tool? You can easily produce that too. According to 5S principles, a neat and orderly work area increases efficiency. Make custom tool holders so that everything has a place. And to move product around the shop, FDM is a great option for transportation racks, bins, and fixtures. Have a robot? You can machine the end-of-arm tooling, but a better option is to make them with FDM. And for a safe workplace, use FDM to make customized guards for all your manufacturing processes. Look around any shop and you will see countless opportunities to improve operations with FDM jigs and fixtures. Quality assurance requires accurate, repeatable holding and positioning to validate products. And once again, they turn to FDM. For coordinate measuring machines, CMMs, FDM fixtures place parts for programming and final part inspections. Without FDM, the inspection lab may resort to painstakingly setting up a fixture each time a part is measured. But once they have an FDM system, they can produce custom fixtures for any shape, even those difficult to hold. Before production parts arrive on the dock, CMMs are programmed using FDM parts and fixtures, so that when production parts do arrive, CMM inspection is completed very quickly. And 5S isn't just for the production floor. In the lab, use FDM organizers for all the measurement tool information, contact strategies, application support.
I think more or less this is the end of my presentation. What you saw was a shortened version of 1 hour long presentation only about jigs and fixtures. We have 6 major applications for industrial applications, and basically every one of them can be talked about at least for 30 minutes. So I truly encourage you all to come up to our printer. Don't hesitate to come up to me and ask questions, or my colleague Dizis, and we'll be happy to share our contact information and to actually help you understand how 3D printing can be used not only in manufacturing, but actually in manufacturing that is present here in Baltic States. Thanks a lot.
Thank you, Janis. Thank you.